I can speak up more if we are.
Okay, guys, everyone, you please put yourself on mute. Okay. So now we will be starting today's topic, that is subnetting. I believe I'm very clearly audible to all of you. So what we need to do, this subnetting topic will be based upon some prerequisites. So number one is you should be very much aware of IP addressing. If you are not aware of IP addressing, you please go to day number 2 video in case if you are new today. So you have to go to day number 2, which is IP addressing in the same series only. And then you can come back to this day number 3 because IP addressing is the prerequisite to understand your IP subnetting and all. So now we will be starting, we can just review a little whatever we have covered yesterday. In IP addressing, we did cover, there are IP classes. It is class A, class B, class C, class D, and class E. Every class, it is significant the way it will be having number of IP addresses into it. If it is class A IP, that means class can, any IP can start between 0 to 127, and you know why we cannot use 0 either and 127 also. And it will have each network, for example, if you will start from 1.000 or 2.000, any network that you will start, so it will have 16,777,216 total number of IPs in each network. Okay, so that means if you are starting class A IP like 1.0.0.0, you will end up at 1.255.255.255. Okay, so this is one thing. Another one is every class A, it will behave like regardless of any network that you are into. So that means any class A network, it will look like this. Your network ID will be network, whatever the number that you have in the first octet, which is this one, this number will be exactly same. If any IP, for example, let's say if I'm asking you a question, IP 1.2.3.4, let's say, if I'm asking you which this IP belongs to which network. So how to sort out this problem? You have to see the very first octet. The first octet is belonging to class A range. So that's the reason it is called as class A IP. In order to calculate the network ID or the network the IP particular IP is belonging to, you just need to follow the same pattern. Put your first octet as it is and make all the host part as 0. Okay. So you have, that means answer to the question is, it is 1.0.0.0. So that is the network that it is belonging. Okay. And similarly, what will be the broadcast ID in a class A? So the class A broadcast ID is network.255.255.255. So that means if you have to calculate the broadcast ID for the same network, it will be 1.255.255.255, right? So this is class A. Similarly, I will be now just be giving you some idea. So here it will look like network.host.host.host, and I'm assuming you will imagine 8 bits in network, 8 bits in second octet, 8 bits in here, 8 bits in here. So total it will be 32 bits, right? Another one is now class B. If you have to change, you have to recall what was class B. So class B range is 128 to 191, and it will have 65,536 total IPs in each network. So for example could be 172.16.0.0, and it will go up to 172.16.255.255. Okay, because you have 16 bits for the host part. So in class A, how many bits do we have for the host part? We have 8 bits for the network, and you have 24 bits for the host. So in case of class B, you do have, how many bits we do have? We have 16 bits for the network, and we have 16 bits for the host part. So that is it. So similarly, there is a pattern to calculate the network ID. So here the network ID for any network, if you identify it as a class B network, so it will be network. Usually it will look like this only. If you have to calculate any IP, that is a network address of any IP of class B, it will be network.0.0. And it is broadcast IP ID will be network.255.255. So that is it. If you want to go for class C, so class C is pretty much straightforward only. This is the smallest class that we have for the host part. It is 192 to 223 and it is having 24 bits for the network. That means first 24 bits are reserved and then you have 8 bits for the host part and it will give you 256 total IPs in each network. Example could be, for example, 192.168.0.0 and it will go up to 192.168.0 because you cannot touch first 24 bits here. These are the network. So here it will be dot 256, not 256, it is 255. And then after that, you will have the pattern like network dot host. Any IP will look like this, and its IP will network ID will be network dot 0, and then broadcast IP will be network dot 255. That's all. So in every class we have private range. In class A, we have the private range as private range of class A. It is from tens network 000 to all the way up to 10.255.255.255. Okay. And class B private range is 172, for example. This is the private range. It will go up to 172.31.255.255. Class C, it is 192.168 dot, either you can use 0.0 or 1.0, and anything will work. 192.168.0.255. This is the range. So every network there is a private range. Okay. So now we in this series, because we are running out of time, so in 30 minutes we can understand the concept of subnetting. So we will start with class C because class C is the smallest range where you can have the IPs and you will be able to address how subnetting topic is being done. So first thing is, you know very well, we have network. You have to imagine like a box. Okay. So now I'm going to start class C IP subnetting. Okay. So here in this case, you have to imagine your network. Let's say my network is 192.168.1.0. I have to subdivide my network into two parts. So what do you mean by subdividing the network into two parts? That means earlier, whenever I'm using this network, I was start giving the IP like this. So my first IP was 192.168.1.1 and the next IP was 192.168.1.2, similarly 1.3, and it is going on so like that. So 192.168.1.255. So but 255 you cannot have it, as we mentioned in the previous day 2 video. Every network we do have network and broadcast ID. So in network your host part is completely 1 and broadcast will be calculating with host part with is completely 1, network is completely 0, sorry. So in this case this is totally 1, all the 8 bits are 1 only, so you cannot have this IP. The valid IPs will be only up to 254. So you can imagine like this is your network address. It will be sitting on the top. It is the label of your box, and this is also out of the box. So these two network IPs you cannot use actually. Okay. In between, whatever the IPs are, for example, 192.168.1.1, and it will go up to the last IP will be 192.168.1.254. These are the valid assignable IPs that people will be having. So in this case, what will happen? You can say is this is a room. In this room, 254 people are sitting right now. Okay, one person is standing out of the room. It is called network address. One person is also in the other end of the room. That is called broadcast address. Total we have 256, but within this room only 254 can be available. So these are the actually workable IPs. So now what you are trying to do, you are trying to have the portion of this network into two halves. So you can imagine in horizontal or vertical line, anything. So now I have to divide this network in such a way that it should be having equal half. So total, what was the range? Range was 256, not range, total IPs. So it is 256. I divided the network into two parts now. So it will give me how many IPs per network. So it will give me 128, which is 128 IPs per network. So now this is my first subnet. This is my second subnet. It will be starting with this IP now, but it will not go to this IP now. It will be ending with 192. Okay, so I'll change the color here. So it will be now, okay, so it is 192.168.1.127 because it will start from 0 and again 127. 127 again you cannot put in this box because as per the rule 0 to 127, which is first and the very last, will be your network and broadcast IPs respectively. So you can use only up to one less than your broadcast ID. So it will be 192.168.1.126. So these are the workable IPs in this scenario. So what about second subnet? Okay, so we said this is the last working IP of subnet number 1, this one. Okay, and this is the broadcast ID of subnet number 1. So that means you started from here, you ended here. And now what about subnet number 2? From where you will start? The series will never be broken. It will be as it is, sequential in nature. So you will have the second IP, the next IP, which is 192.168.1.128. This is the next IP in the series. Now this will be your network address for subnet number 1. So this is also out of the box. What you will put within the box? First workable IP will be 192.168.1.129. So that is how the things will be working. And it will be going up to 255. So if this is okay as per this logic, 255 now will be belonging to subnet number 2. It is not the same network now. You have subdivided the network into two parts. Earlier, it used to be the broadcast ID of overall the network. Now this is the broadcast ID of subnet number 2 only. So now the 254 IP will be falling into the subnet number 2. What the major change has happened here? Earlier, all the IPs from 1 to 254, they were free to ping each other. They were free to talk to each other. But now you can ping only between this area. That means from 1 to 126, they are free to talk to each other. But any IP from subnet number 1 or subnet number 2, they cannot talk across, which means subnet number 1's IP cannot talk to subnet number 2 and subnet number 2 will not talk to subnet number 1 now because they belong to different subnets. So now subnet number 1 is this one, which is network ID is this one. Subnet number 2's network ID is this one. Okay, so that is how you will subdivide the network. So now we have to practice the same thing accordingly. How you will be calculating the network and broadcast ID in this case. So let's say just Okay, I'll be just removing the screen video. Sorry, annotations. So now first thing is you had the network called 192.168.1.0 and it was /24 because the 24 bits were for the they were used for the networking part. You divided the network into two parts. Okay, so that means earlier it was looking like network and 8 bits were for the host part. So network, again network, and 1 2 3 4 5 6 7 8. So that was the situation before you actually subdivided the network. Now what has you have done, you subdivided the network into two halves, equal halves. So now 128 IPs are here, which is from 0 to 127, where 0 and 127, they both, so 0 to 127 will be your 0 is your network ID and 127 is your broadcast ID. Similarly, in subnet number 2, again you have 128 IPs only here. So in total, now you will end with 128 and you will go up to 255, and the workable IPs will be, you will assign 129 to the first fellow in subnet number 2 and the last fellow will be ending with 254. So that is what you have done already. So how this change has occurred, how now we are ensuring they are not talking to each other. So what is the difference between, because we were having the same IPs in subnet already, the previous subnet also, which was only one. Now just changing their IPs and changing the series will not make any difference, right? So this change of IPs is not been done here. The change is actually done here. So basically what you have done, this bit from the very first bit, which is 25th bit here. Why it is 25th? Because 24 bits are already here. Networking bits, you have 24 bits in binary here. So you have 25th bit, you fixed it that for subnetting. So that means earlier you were having 24, now you have added one more. So now your subnet mask is no longer is 24 bits, it is /25. The first change occurred is this one. It is /25 now. Second thing is, this bit is distinguishing your subnetting portion, whether it is subnet first one or second one. So what is happening now in this subnet number 1, your network is looking like this: network.network.network. This is my subnetting bit 1 2 3 4 5 6 and 7. This is my host part. Now you are only left with 7 bits of the host. Earlier you had all complete 8. So that is the reason 2 raised to power 7 means 250, not 256. It is now 128. So 0 to 127 is your range now. Similarly, in this case, network.network.network, again subnetting bit, and then 1 2 3 4 5 6 7. So but in this case, what is happening? Your subnetting bit is, in this case, is set to 0. So that is network.network.network 0 and then 1 2 3 4 5 6 and 7. Similarly, in this case, so similarly here the logic will be applied here also. So it is network.network.network. Now it is 1. Whenever you will be borrowing the bits from host part, you will be keep on increasing the subnetting bits. Those subnetting bits will be following the binary logic. If it is 1 bit that you have fixed, so this 1 bit will be giving you 2 combinations. If you would have borrowed 2 bits, then these will give you four subnets. That is 1 0 0 will be the combination, 0 1 1 0 and 1 1 will be the combination. So these bits will be fixed. So now that is 1 2 3 4 5 6 and 7. That is what your second subnet will look like. So if I want to calculate my first subnet ID here, whatever the IP you have, whatever the network you have, what you need to do, you need to put all the host part here 0. Now this is not 0. This is no longer your host bit. This 0 is already now just fixed, fixed it just like your networking bits. So you have to remain with this 0 all the time. So what you will be doing now, it is network dot network dot network. This 0 is the part of your network now. But next, whatever the bits I'm giving here, so here these are 0, 0, 0. So just to make the difference, I'm just giving them star 1, 2, 3, 4, 5, 6, and 7. So these are the host bit zeros that you are making. And what will be the broadcast ID in this case? It is network dot network dot network dot, this again is fixed 0. You cannot change it. But now the host part you will completely put 1. So it is 1, 2, 3, 4, 5, 6, and 7. If you will calculate, it is already 0, this part is already 0, and making all the host 7 bits will be 0, it will give you the final value in the last octet as 0 only. Similarly, in the second case, which is your broadcast ID, you have 7 bits for the host and all the 7 bits are 1. So it will give you 127. And the valid range is in between. So that means valid range is going to be, I think it is not very visible. So valid range will be from 1 to, it is from 1 to 126. So same logic you have to apply here also. It will be now network dot network dot network, and then you have 1 is fixed, and then you have all the host bits 0. So that means 1, 2, 3, 4, 5, 6, and 7 stars. So now if you will calculate, this network part will be the last part. That means the network address going to be 1 network dot network dot network dot 128, because the last MSB is 1 only. So that is your starting of the next subnet. So this is a subnet ID now. It's no longer one valid IP. Previously, it used to be the valid IP, but now it's not the case. It is representing the second subnet because it is out of the box as per our discussion. So then what will be your broadcast ID? It is network, network, network. Then 1 is again fixed. And here you will put all the 1 only, which is now for making the difference. I'm representing this exclamation mark just to say 1, all the host part 1. So it is 1, 2, 3, 4, 5, 6, and 7. Okay, so these are 7 ones only. Imagine. I'm not putting the normal one, so that you should not be confused about, okay, where is the subnetting bit and where is the host bit. So now you have to calculate the value overall. So it will be 255. And the valid range will be from 129 to 254. That is how it will work. So this is all about your class C subnetting. Okay. So whenever, if you will subdivide the network into 2 parts, that means 1 subnetting bit you are going to have here. If you want, you can divide the subnets into 4 parts also. In that case, what you have to do, you have to focus here. So you have to have 2 subnetting bits now. So it will look like S here and S here. And now you are going to shrinking down the host part. So it will be 6 host bits. So that means 2 raised to power 6. So it will be 64 IPs. And you have borrowed 2 bits. That means 2 raised to power 2. You will have 4 subnets like this: subnet number 1, subnet number 2, subnet number 3, and subnet number 4. Each subnet will be having 64 IPs into it. So it will be from 0 to, first subnet will be looking like 0 to 63. And the valid IPs will be 1 to 62. Similarly, the second subnet will look like 65 to, and then you calculate other subnets like that. That is how the things will be working. And when you mathematically, when you will be proving, here it will be, there are 2 subnetting bits. So that means subnet, subnet, and then this 6 bits will be for the host. Okay. So you have to calculate the subnets like that. Let me draw here. It will be subnet, subnet, and then host, 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 3, 4, 5, and 6. So it will be 0, 0, and then 1, 2, 3, 4, 5, 6, and then 0, 1, 1, 2, 3, 4, 5, 6, then 1, 0, 1, 2, 3, 4, 5, 6, and then 1, 1, 1, 2, 3, 4, 5, 6. So these are now 4 subnet. This is your subnet number 1. This is your subnet number 2. This is your subnet number 3. And that is your subnet number 4. So what will be the network and broadcast ID? You just need to calculate the last octet. First put all the host part as 0. So it will be ending with 0 only. And then after that you put all the host part as 1. It will give you 63. Then the second one, you start with 64, 5. And then later on you will end up with certain values like 127. And then you will start with another values like that also. Yeah, Satyam?
Ma'am, how to divide in odd parts like 3 and 5?
In odd parts, actually, yes, it's a good question, actually. So, as per the binary logic, if you have the requirement for 3 subnets, let's say, but basically there is nothing that can give you 2 raised to power something, it will never give you 3 because binary logic won't work in that case. So you have two approaches. Either you can go for this way only and you can say minimum I will. Sometime the subnetting question in CCNA exam is also like this. You have to subdivide your network in such a way minimum 3 subnets can be done there. So you have to calculate the number of subnets in such a way. You should not waste too many subnets also, and you should be very near to the requirement. That is called as per the standard binary logic. So you will have a fixed length of subnetting in this case, and that is equal length. But if you want have to have 3, 5 and all, so that you follow the different pattern. Maybe let's say you imagine here, I have one network. First, you divide the network into 2 parts. Again, you subdivide the network, this network into 2 parts. This is one technique, okay? So that you can use in order to divide the network into 3 parts. Again, it will be following the rule. So what will happen when you have subdivided the network into 2 equal parts? It was giving you /25. And here also it was /25 vertically because you divided the network first into 2 parts. Now focus on this part only. You divided this network into further 2 parts. Now this part is 26 and this is also 26. So this is variable length. So that we have the technique called fixed length subnet mask, variable length subnet mask, CDR notations and all. So you can always go like this. If you have 3 subnets and your requirement is fitting inside it, you can approach like this also. Even if you want, you can go subdivide. But it is again, you see, minimum one network you are subdividing into 2 half. And that is the reason you can go in odd number of subnets also. Normally, if you will be working on subnetting overall, so it can go as per the binary logic only. Make sense?
Yeah, yes, ma'am.
So again, it will be depending upon the requirement. What will be your requirement? If your requirement is getting fulfilled in this way, you can go like this. Otherwise, let's say somebody is asking you, you have to subdivide your network into 3 parts, and each part will be having, let's say, 64 IPs into it. Okay, so that now you have minimum, they said you need to have 3 subnets. Each subnet will be having 64 IPs. Now either you can divide on this basis or that basis. Here, if you will be calculating number of host, that means 2 raised to power something will give you 64. That means minimum 6 bits for the host you have to fix. Remaining 2 bits you can go for subnetting. That is also the way you can calculate the subnets. So in this case, you will have 4 subnets and 1 subnet you can keep it for your future use. You can have minimum 3 into that. Or otherwise, if let's say in this case, what will be the scene here? You can have 128 IPs in this case if your IPs are variable, and then 64 IPs you can come over here and 64 IPs can come over here. This is also one way of achieving it. But it again, I'm saying it is depending upon your requirement. If your subnet number 1 is pretty high, then only you go for this one. Otherwise, if equal subnets IPs are required, then go for fixed length subnet masking. Okay,
Yes, ma'am.
understood?
Yeah, yes, ma'am.
Okay, so do we have any other question? Okay, one thing I want to announce, I will be putting one extra announcement also. We will conduct one quiz in the last day. So we will be having some, let's say it's just to promote network security as the background, that because that's my own area of expertise. So it is like I will be welcoming all the people who are very much interested in this field. So there will be a kind of competition. It is open to everyone, specifically people who will be for here for next 10 days only. And we will have some good, some sort of gifts for them also. So let's see, I'll try my best. But you need to participate in that quiz. So that is all. Any other question for me now? Okay. Then we are all good to go. So so tomorrow's topic again. So again, I'm saying each day is decided and planned in such a way. Day 3 cannot be completed without completing day 2. Now day 4 cannot be completed without day 3. So tomorrow's topic is totally depending upon today's discussion. So you have to be a little bit quick. Okay. So tomorrow we will talk about some sort of network address translations and all. So we will go for your netting part. Okay. So, all right. So I'm just going to stop sharing my screen. So thank you everyone. Nagul, Tejas, Satyam, Kabir, everyone. Thank you so much. So let's see tomorrow how the things will go further.
Thank you,
Okay.
ma'am.
Okay. Take care.
Thank you, ma'am.
And bye, Tejas. Good night.
Thank you.
Bye-bye.
Bye, ma'am.